Hello and welcome everybody. We are just about to get going. There's still quite a number of people coming on, so we're going to give it a few more seconds, but we will be getting going very shortly. So thanks for coming in on time, and we will be back in 10 or 15 seconds, or maybe even 20 seconds, and we'll get going then. So just bear with us whilst we let everybody coming in. Okay, well, hello and welcome everybody to our Cassandra Masterclass webinar, where on this masterclass, we're going to be diving into everything you will need to know on backup and restore in Cassandra. So I'm Steve Benton, and I'll be your host for today. I'm also part of the team here at AxonOps, who are hosting this masterclass event. Now, we've got a really good lineup of discussions and demos for you, and in case you would like to review our masterclass again, you will have the opportunity because we're going to record the session, so we'll make sure that we get you the link afterwards. Now, of course, everybody, any masterclass, we've got to have masters, and we've got our own masters here today. We've got two of the finest in the house, so let's introduce them to you and get them up on stage. Here we go. So we've got, first up is Johnny. Hey, Johnny.
Hello, everybody.
Good to have you with us. Why don't you just share a little bit about yourself before we introduce our next master?
Yeah, so I'm Johnny Miller. I've been using Cassandra since 0.6, which is nearly 15 years away, and pretty much used it on every type of system I've worked on since then. And I've done architected systems, developed systems, deployed Cassandra, looked after Cassandra, and pretty much every kind of problem I think you can encounter with Cassandra, I've had the fortune of experiencing.
That's great. And I know that you're going to be sharing a few of those a bit later on today. So thanks for coming on. And secondly, we've got Hayato in the house. Welcome, Hayato.
Hi, everyone. My name's Hayato. And just like Johnny, I've been using Cassandra for about 15 years. And we've been operating on a very small to large clusters, putting them into enterprises. Backups have always been my favorite topic.
That's great. Right, let's get going now. As I mentioned, AxonOps are hosting the webinar today, and I promise you this is the only marketing slide that we've got. But for those that don't know AxonOps, it's really important to understand AxonOps. It unifies the monitoring and operations of Apache, Cassandra, and Kafka via a single intuitive user interface. Now, there wasn't really anything like this around, and it caused quite a big problem. So AxonOps was actually built by veteran data platform experts who, as I said, were pretty frustrated with a lack of effective tooling. So AxonOps now meets the demands of critical workloads globally across multiple industries and use cases. So it's good to understand that. Okay, well, look, it's great to see so many of you joining us. There's still some of you are coming on. If you've just joined, you've not missed too much. We are just getting started. Now, this is very important. You'll see that you've got a Q&A on your Zoom. Now, part of this masterclass, well, a lot of this masterclass really is to help you. And one of the ways we can do that is to answer your questions. So if you have a question for us, and it could be on a subject that we're talking about, it may even just be generally in Cassandra. You know, we've got the experts here. You know, fire away. We really want to help you out as much as we can on this session today. And so please do use your Q&A. And we may take some of those questions and explore them some more as well with our wider audience. So let's get going. Johnny, why don't you kick us off by covering the importance of backup and restore?
Cool. So hello again, everyone. So really what we're here to kind of talk about is why backups are important with databases in general, but also including Cassandra, and really then some specifics around how Cassandra does it, what options you have, and try and show you some best practices and things like that. And as Steve mentioned, we're here to answer questions, so please do drop in any questions into the chat while I'm talking, and let's get started. So the first thing I always suggest you think about very carefully is if you're not backing up your Apache Cassandra clusters, well, what are the kind of costs that of not backing up your database? And there's some fairly good statistics out there that really illustrate how important this is to do. There's some stats there. So the average cost of a data breach in 2023 was nearly $4.5 million. The cost of businesses for small data losses, $18,000 to $35,000, losing about 100 plus million records, $5 million to $15.6 million. And if you have downtime, depending on your company size, between $10,000 and $5 million per hour. And there's also some really more worrying statistics you can look at around the effect on companies that who don't do backups, or their backup strategy wasn't good enough. And 94% of companies who suffer catastrophic data loss do not survive. Yeah, and of them, you've basically 43%, they never even reopen, and the rest, they usually close within 2 years. And that's where you've got nothing to come back to. It's the end of your business. And even if you're a small business as well, if you're just out for say 10 plus days, you generally are going to be filing for bankruptcy within 1 year, which is kind of worrying. And 60% of small businesses who will close within 6 months of a significant data loss. So there's real world impacts to your business if you're not backing up. And if you look at the specific sectors that a lot of people are in, you can even apply more to them. So the healthcare sector, the average data breach cost is $10 million, which is pretty high, and that's actually one of the highest across all industries. In the financial sector, the average data breach cost is around $6 million. And then in the industrial sector, the cost of those data breaches have been growing year on year significantly. So there's a genuine financial cost. You can put money to it, but also just the straight up survival of your business is part of this. So it's an important thing to be looking at. But it isn't just about that. There's also laws and rules that you do need to abide to, regardless of whether you want to or not. So one of the important one is, say, in financial services. If you're in financial services, SOX compliance requires you got to keep 7 years of your record. So obviously your backups are pretty important. If you're in healthcare, HIPAA, which is a healthcare standard, they mandate you should be taking regular backups and disaster recovery testing as well. So it's not just taking the backups, it's showing that you can actually restore. Similarly, if you're under GDPR, Article 32 requires regular testing of your backup effectiveness. So kicking the tires, taking those backups in there. And similarly, a lot of industries are in PCI, so taking credit cards, you're required to keep a daily backup of all your cardholder data. So it's not just the cost, it's not just your business, it's the law in a lot of places as well. And there's plenty of real world examples where an ineffective disaster recovery backup plan has caused massive costs. And here's just 3 examples. You can find a lot more out there. Maersk, they got a ransomware attack, and they lost approximately $300 million, and it caused massive operational disruption due to insufficient backup strategies. So it just took them so long to come back, cost them so much money, and they probably learned from that mistake. Code Spaces, that's another one that we might all remember hearing about recently. This entire company was destroyed in 12 hours. So hackers got into their AWS console, deleted everything, and most importantly, deleted everything, including their backups. So that company ceased operations permanently, and all of their customers' data, all of their code repos, they were all gone and lost. And the really important point there to take away is they were still able to delete your backups. So even if they get into your AWS, make sure your backups aren't in the same place as well. British Airways, they had a DR scenario, and essentially they had no proper backup system to get to when their main data center went down. And they had to have $150 million in compensation, and they lost 380,000 customer booking transactions, let alone the reputational damage to British Airways on this happening. So you can see there's real world examples there for why that's important to do. So
well, Johnny, I was going to interrupt you if I may, because I'm hearing what you're saying here, and I'm not a technical guy, but I thought Cassandra was a highly available database. Isn't it not replicating in other data centers? So Why is this so important?
Yeah, I mean, for sure. I mean, great, good question. So why back up a highly available cluster? Yeah, well, simply put, I love Cassandra. It's a great database for adding data centers, AZs, racks, mitigating those single points of failure in your system. But you've always got to remember, replication is not the same as backup. Yeah, what that doesn't save you for is all those things that can still happen when you're replicating your data: human error, hardware failure, software bugs, cyber attacks, natural disasters, failed data migrations, poor backup strategies, losing data centers. So just because you're replicating doesn't mean you're solving all the issues that can happen. And if you look at those examples showing you there, not all of them relate to not having a backup. It's just doing the right thing with your backups or testing those backups. So you got to remember what a backup is doing. It's protecting you against accidental data deletion, corrupted schema changes, malicious attacks, multi-data center failures, all those things that could happen. And also importantly, the failure time, the recovery time objective from failure. It's not often a question of, is my data backed up? Can I get to it? It's how long does it take me to get that data back and my business up and running? So having backups gives you a faster recovery time objective. Now, we're talking about Cassandra. So in Cassandra, there are some critical parts that you should be looking at when you're deciding on how you're going to back up your Cassandra cluster. The first one I call out here is your system key spaces. In my opinion, even if you choose not to back up your data, at least back up your system key spaces, because it's not a lot of data and it really helps recovering from issues, failure, nodes going down, coming back on, etc. It's a very simple, lightweight thing to be backing up. It's not a lot of data. It will make your life a lot easier if you're backing up the system key spaces, your system data in your Cassandra cluster, if you will. The other thing is your user data, your actual application data in there. You should be backing that up also. And it's obviously a critical part of what you're going to back up in your database is the data in it. And importantly, your configuration files. Now, I don't say configuration files in the sense of you need to be taking a tarball of your config or anything like that, but you should be looking at having your cluster under some form of configuration management where you can get it back to the same state. So when the point being, when you're recovering from a disaster and maybe you have to re-provision, set up all your clusters and bring the data in as well, you need to make sure that your configuration is in a known state as well. So it's important to make sure the config is part of your backup as well. Use tools like Salt, Ansible, Chef, whatever you like, but make sure you're doing that also. So when you're looking at backups, there's a couple of considerations you need to take on board. The first thing is location, all right? Your backups data should be stored ideally geographically separate from production. If your data center gets hit by a plane and all of your backups are in the same data center, well, you've lost your backups. So making sure your backups are put somewhere with redundancy that's going to be not in the same failure zones as what your actual database might be. Security, and this is a really important one because backups are a really attractive attack vector for your systems and your data because they're typically sitting there off to one side, possibly not being monitored in the same way your actual production database yet. But you can get a heck of a data leak coming out of your organization if someone gets just at your backups. And it is a common hack that people get through is to their backups. So it is important that where you put your backups, that you're encrypting them at rest, you're encrypting them in transit, and really importantly, the access control around those backups. So if you look at one of those failures, it was all in the AWS console, the same place. I get in there, great, I can go in and delete the backups as well. So access control around that data is important. Ideally, nobody has access to it until they need to get at it. So think about that also. Accessibility, yeah. You need to be able to get at this data in an emergency. It's great if your backups are sitting there on tape in someone's drawer, but that's going to take a long time to get recovery in there. So choice of accessibility for quick retrieval when you need that data in an emergency as well. And also cost. This is usually the one that comes out, is how expensive is it to store these backups where you're choosing to store them. And then finally, alerting. You have to monitor your backups as well. You need to be making sure your backups are succeeding, or if they're failing, you know about it. You need to be able to check what it's backing up is what you expect to back up. So monitoring your backups and ensuring they're a success is equally as important. And then think about retention. Yeah, this kind of plays into cost typically, or your regulation requirements. How long am I required to retain my backups? So you need to manage that retention. You need to purge that data when it's not those backups when they're no longer needed, keep them for as long as they have to be needed, but have that retention defined and something that you're very much aware of what you need to do. So the other important part of your backup plan is testing it. Yeah, if you are not comfortable and familiar with dealing with a backup and restore scenario, it's not going to be, you're not going to have a good time. So it's generally good practice to practice it. Okay. So the first thing often people do is they'll do perhaps a monthly full restore test to a staging environment to check that the restore of their data works, that the time it takes to do it works. Nothing weird has come into the system that you're not aware of. So constantly sweating and testing that backup and restore on a regular basis not only checks what you're backing up is correct, but also gets you familiar with it and used to doing it. The next one is perhaps a quarterly disaster recovery simulation. Test your disaster recovery. Try it. Try failing over. Try dealing with these. Try removing various aspects of single points of failure in your system, what you're required to look after. So that quarterly disaster recovery plan is a good thing. Often I've seen places where I believe it's even a regulatory requirement to exercise this as well. But the other part of your backup testing plan is validating that the backup and restore works. So have those data integrity checks. So you know the data I've restored and I've verified the data I've restored. Is my schema the correct way? Is my app still behaving in the correct way? Is my performance degraded? Have that necessary instrumentation around your cluster so you can detect these things. If I've done a restore, but all of a sudden my performance degradation is changed or my load profile has changed. So understanding that and being able to validate that it's worked is important. So Cassandra itself has built into it some great features to help you take backups that you'd expect any database to have. The first one that most people are probably familiar with is snapshots. There's a command utility shipped with Cassandra called notool, where you can call this command notool snapshot, giving it a tag name if you like, and telling it what to back up, all your cluster, a key space, a table, whatever you like. Now, what a snapshot is doing is essentially when Cassandra is writing its data files to disk and flushing them and compacting them, what a snapshot does is it creates hard links on the file systems to a directory and retains those data files under that directory. And what this means is that when the snapshot is taken, it's an immediate snapshot of the data at that point in time when you ran the command. And this is pretty quick, pretty useful, very simple to do, and it's very common to have this type of thing scheduled to take these snapshots regularly. The other feature, which I think a lot of people are less familiar with, is commitlog archival. And this is the feature that gives you the ability to do proper point-in-time restore. Now, what you're doing with commitlog archiving is as Cassandra writes to disk, it makes those writes durable by writing to a commit log on disk. And these commit log segments get recycled. And what we're doing with commitlog archival is copying those commit log segments off somewhere else that they can be used later to restore in there. Now, one of the reasons why this is not something we see very often is it is quite complex and fiddly to get working, but you can do it. You can script this, you can get this working if you put the effort in to do it. So it's an important part of any backup plan. If you need point in time restore, you should be looking at commit log archival. Another thing Cassandra's got is incremental backups. Not something I have to say I've ever seen in production, but it is a feature of Cassandra. And what incremental backups are is when your mem tables get flushed to disk as SS tables, it creates hard links to those data files. So not the compacted out data files, just those flushed mem tables to disk. And what you end up there was a lot of very little files in a directory, but they're there. It's a feature available for you to use. Now, other tools you've got in there is auto snapshot. This is a feature in Cassandra where if you go in and drop a key space, drop a table, truncate a table, it will automatically take a snapshot of that data for you. And I can tell you, this is a lifesaver. Yeah, I would suggest never turning this off in production. It is on by default. It has saved people many, many times. And I rest assured, it's one of your best friends if this happens, if you accidentally drop a table, you know there's a backup there before it. But you should consider the retention of those auto snapshots as well. And with later versions of Cassandra, there is configuration to allow you to say, how long do I keep these snapshots around on my local disk as well. And then the final piece in there is another piece of configuration called snapshot before compaction. Now, I have to say again, I've never seen this on in production, but what this does is essentially every time compaction kicks off in your cluster, it takes a snapshot of your data. And if you don't know what compaction is a background process in Cassandra that's continuously grooming the data at disk to make it efficient for reads and get rid of data that can be deleted. And this is a feature that allows you to do this. But be careful, you can end up with a lot of data sitting around that you might not want to keep. So
just on that point, Johnny, I've got to admit, just going to the previous slide there, I've got to admit, I did do that mistake of dropping a key space in production, a wrong key space, dropped it. And when that happens, the blood starts kind of draining from your head and, it starts shaking. And that's actually happened. But this feature, Auto Snapshot, did actually save me. So we were quickly able to restore all of the, the data files because of that feature. So, do have it, and it is enabled by default, but keep it on there. The other question is, Johnny, by having all of these kind of backups, how do you, is there anything within Cassandra that manages the retention of these backed up files?
Yes, there's in later versions of Cassandra, there's various configuration options now, which will allow you to say how long to keep these auto snapshots around, things like that. And there's more and more coming in, but I think they start to come in 4.0 and 4.1. But yes, there is config to allow it to automatically throw away the snapshots after a period of time. But it is an important one with the auto snapshot, because sometimes people forget these snapshots are sitting around and you end up filling your disk. And it is a good thing to point out. So if you look at the directory structure on disk when you're in Cassandra, this is where these snapshots will be kept. So you have your data directory, key space, table. Then underneath that table, there's two directories where your snapshots or incremental backups will be stored. And this is what you're looking to do. If you take those snapshots, you got to get them off server, put them somewhere where you'd like them to be. So that's how it looks on disk. There's a great tool out there called Medusa. Medusa is a very handy tool for backing up your Cassandra data. It's quite popular in the community. It was originally developed by Spotify to address, I think they had an incident with their backups and they said, oh, we can't have this again. Let's come up with a better tool to do this. So they created Medusa, they open sourced it, and then it was picked up and enhanced by a company called The Last Pickle. It's completely free. It's up there on GitHub, and it's got some great features in there that will help you. It supports both full and differential backups. You can back up and restore to single nodes, clusters, selective restores of key space and tables, all of the things that you want to do, and it supports those backups being moved to various back-end options. But there is an important thing to point out. It does not support point-in-time recovery through commitlog archival. So if you're going to go down with Medusa and you want that point-in-time restore piece, to make sure to still look at how you're going to manage your commitlog archival and the restore around that. But Medusa is pretty popular, worth having a look at for sure. So backup best practices, in a kind of an ongoing basis, there's some good best practice you should look to follow when you're looking at your data. So the first one I always suggest is always take a snapshot before you're doing a schema upgrade. Yeah, if you're going in there, altering tables, dropping tables, all that stuff, just take taking a snapshot should be, or backup, it should be, that should be habit for you. If you're doing an application upgrade, the amount of times people have done application releases, introduced a bug, have to roll back, and then even worse, if you can't roll back, you've got to pick it apart to figure out what it was before, what it was after. Not knowing what it was when before the application was upgraded is going to make your life really, really hard. So get into the habit. You're doing a big release, you're doing an application upgrade, take a backup. Migrating data, that's a funny one, and often you have people copying data around between systems, between tables, and often part of that data migration is deleting the source once you've copied it over to the target. And I can say from personal experience, I have found myself deleting the source at the wrong time, and my target not being right and being, oh God, I've deleted the data and I've lost it. But because I did a backup, my life was good. So when you're doing stuff, moving data around, transforming data, do a backup. You should also automate the verification of your backup so you know it's worked, and also document the restore procedure and make sure you've trained multiple team members on how to look after backups. So key takeaways. Backups are your insurance policy. And like any insurance policy, when you need it and you don't have it is when you regret it. Yeah. So look at those statistics, look at your business, look at that, what the effect you could have, the catastrophic effect you can have on your business if you're not backing up. Test your restores regularly. Yeah. The number of times where you have a backup gone, you restore, and then what you think you were backing up hasn't been backed up, you're in a bad place. Test those restores regularly. Automate everything. Yeah. You do not want to be SSHing onto nodes, running commands, SEPing, rsyncing files around. All of this should be automated, not just the backup, but the restore process as well, because you don't want to be in there in the middle of the night, writing out bash scripts to stream stuff around, anything like that. Make sure everything is automated as well. Document everything. Have some form of operational runbook that you can give to someone with step-by-step instructions for what to do in the event of failure and how to react to it. It doesn't have to, it's an important thing to have. It's a good exercise to do because it means you've thought about it, you've put it there, and it's ready to do. Train your team. Yeah. Everybody on your team should be comfortable with doing this. And that's it from me. So next section, conversation corner. Let's have a chat.
Well, we've got some good questions coming in. Not that many, so audience, get your questions coming in. Let's get these guys working really hard. And thanks, Johnny, for that. Now, one of the most common questions that we get coming in, and maybe we should just start with that one. And I want to bring Hayato in as well. So Hayato, come and join the conversation here. How do you define your backup plan? Is a very common question that we get.
Yeah, it usually actually comes up really frequently. What should the plan be? What should I be looking at? How do I figure out what I got to back up? How long I got to back up? And really, there's three things you should be considering, and there's three things you should be discussing with your business around your backup plan. The first thing there you should really get is RTO, recovery time objective. And what we mean by that is how long to restore, how long to recover from whichever disaster you're planning to recover from. RTO, and that's a conversation you need to have with your business and then that's the target you're working towards when you're actually practicing your backups, practicing your restores. Can you meet that RTO? And then if you can't, then you have to figure out what needs to change to do that. RPO, recovery point objective. And this is a bit more of an awkward conversation to have, because really what you're saying here is how much data can I lose? Yeah. What is what is the specific point I have to be able to get back to? If somebody says I have an RPO of 1 hour, well, that means I can afford to lose 1 hour of data. But having that conversation, articulating it, and making sure it's clear to everyone is really important as well. And the final one is always going to be budget. Yeah. Because all of these levers that you're pulling, there's a financial consequence to doing it. And if somebody puts in, 0 RTO of 5 minutes, well, then you have to have the budget in there to make the database, the deployment of that database work with it. Hayato, anything?
Yeah, so I often get asked this question around, what should we do around the backups? And whenever we kind of, going to these types of enterprises, kind of having this conversation around, all right, we need to implement backups. That's without a question. But what do we do? And I think we, going back to what Johnny was saying around this regulatory requirements as to, or is it like financial services, what are the SOX compliance requirements, and then what kind of data is it, etc. Having these kind of conversations is important. And then the other aspect of it is the understanding of the failure domains. Is it multi-data center deployments? What's the replication factor? Have you deployed across racks? What are those kind of failure domains is also important. So having the scenarios well defined upfront, say, okay, what is the failure domain or node level failure, rack level failure, data center level failure, And then having a plan for each of those failures is important. The other aspect is logical failures, right? So having, things like, or what do we do if I accidentally delete the database files, accidental failures, or logical failures by deleting the key space, things like that. So having a plan mapped out. So that will also define the RTO. What if I lose a node? What is the recovery time objective for that? What is it if I lose a data center? It helps you define those kind of information, and you can present that to the business, say, hey, look, technically these are the sort of things that you need to think about, and these are what's possible in terms of recovery time based on the technologies that we use. Again, recovery point objective as well. Johnny talked about, is it 1 hour? Is it like an exact point in time? Often that financial transaction data, you want that exact point in time restore capabilities, which means you are going to have to kind of put in the commit log archiving and restore procedures in place as well. So yeah, do think about what is actually required by the business. Have a conversation with your business, all the rest of the teams, and then raise this and say, look, backup is not quite binary. You've got to think about what you're backing up for.
Oh, great. Okay. Well, look, final question really quickly on this one. Why do I need commit log archive when I'm using snapshots?
Well,
and we'll just be really quick on that one, and then we are gonna move on as well, because we've got some really good stuff lined up next. So who wants to take that question?
Yeah. All right. So essentially, and as I kind of explained, snapshots is an exact point in time when you have taken the snapshot. Now, you're not typically going to be taking the snapshot every second, every minute. Typically, you are taking the snapshot, every several minutes, maybe every hour. And then what's going to happen in between? Well, you're still going to have ingest of data coming into the databases. And it's a continuously moving target, and that's what the commit log archiving offers you. In that, if you are backing up the commit log archives, what you're able to do is you take the snapshot, restore that, and then you can add the commit log back into the commit log directory and play back that commit log to a specific point in time to restore to a point in time that business requires you to restore to. So yeah, that's why you do need both. If you have that, point in time restore requirements from the business.
cool.
Good. Okay. Well, look, guys, we've covered the importance of backup and restore. Hayato, I know that you want to now take us into the next section, which is sharing some of the best practices of how we can make backup and restore much easier for our Cassandra developers through the lens of AxonOps. So how do we do that then, Hayato?
Sure. So I've just got a demo cluster of 3 nodes here, but we've been kind of implementing backups in various places over the years. Well, I was writing Python scripts or just Bash scripts. In early days of use of Cassandra, Johnny and I actually used to work at a company called Sky, and we've implemented these solutions manually ourselves. But then over the years, we've been looking after very large clusters, and those kind of tooling just did not scale for us. So we just built a kind of reference implementation of the backup and restore systems based on those kind of good things that we discussed earlier. In terms of the snapshots, you want to be able to schedule the snapshots based on the business requirements, or you can, as Johnny talked about, kind of taking a one-off backups when you need to. They're doing kind of some major operations in Cassandra cluster and being able to take a snapshot at that point. So this is an implementation through the GUI, but of course there's agents running on the Cassandra to be able to facilitate these kind of immediate backups, scheduled backups. Being able to specify the data center you're backing up, key spaces, tables, etc., or specify a regular kind of backup schedule, snapshots in schedule, allows me to just kind of define these things very, very quickly. And then once you kind of define what you want to back up, then you can say, all right, I want this taken off-site. And location, I think Johnny mentioned earlier, is really important. You want to be able to push this out to a remote location outside of the data center that you're running your Cassandra in, right? I know you may have heard of OVH data center burning down. Really, terrible disaster for many companies that were using that data center. And people did back up their data in the same data center and lost it all. So, being able to define the remote location whereby, okay, I want to back up to an S3 and I want to be able to choose the region away from my existing Cassandra region and so on, right? Is really important, and we've implemented that. But you can do this yourselves. It's as I said, it's just a reference implementation of backups we've done. Security is another thing that Johnny mentioned. It needs to be encrypted. Nobody has access to it, etc. So being able to define the encryption of the backups, very important. The accessibility. So now you've got these amazing kind of cloud platforms do provide great access solutions. Do use it. Don't let anyone else look at your backups apart from the backup system itself. Humans should need access to it, etc. Right? So do kind of lock it down, and you've got facilities here to be able to do that. Audit. Yeah. So you have to be able to demonstrate that you've got the entire backup history. So being able to see all of your backup history, again, very important. Again, this is a reference implementation, knowing all of the nodes in the cluster and all of the tables and key spaces got backed up, and in that instance, what kind of backup method it was. Oh, it says incremental. Oh, let me talk about two types of backups. We have here is the incremental or full backup. In Cassandra, the data files are immutable, which means once they're generated, then they don't change. So when you push it to a remote location, that data file could be the same as the previous snapshot data file. So incremental means that you don't actually need to store the same file over and over again in remote storage. What it does is generates a manifest file, and then that describes the snapshot and the content of that snapshot. So that also gets backed up with remote storage. But Medusa works the same way. I think all of the Cassandra snapshot restore backup mechanisms work the same way. But yeah, having a history of those each individual snapshot and remote storage is important. And then finally, in terms of the Cassandra backups, we talked about the commit log archiving. Yes, you can kind of configure Cassandra node individually to do the commit log archiving, tell it what to do. We've actually gone away from that to be able to define exactly where we want to push the commit log archiving. But again, it's a reference implementation. You can do this yourself, but here's an example of how you could do this. Okay, so choosing what data centers to back up. So if you look at this one I configured earlier, you can see that it goes to an S3 to this bucket and so on. So if we have a quick look at this in the S3 storage, I can browse down to, that's a node, that's commit logs, date, time, stamp, and all of my commit logs are there. So I'm really, really happy. All right. Restored. Yeah. So as Johnny said, really important to be able to restore the backups and rehearse it. Yeah. So as with any kind of systems that you use, you should be testing it, even with Medusa or AxonOps. So let's just talk about snapshot backup restore. Being able to pick and choose the exact snapshot you want to restore is important. So you pick one, and then sometimes you only restore into a single node, perhaps only a single table, and perhaps sometimes you've lost the entire node and you want to restore the entire node or entire cluster. So having the ability to quickly decide what to do in the case of different failure domains and the failure scenarios that you want to cover is important. So Again, no, this is a reference implementation. Just pick and choose what you want to restore and allows you to restore. I'm not going to do the restore now. The other one is the point in time restore. So, we talked about, sorry, go back. So we talked about, this is the timeline, right? And you can see these snapshots that have happened on this cluster, and then being able to, go to a specific point in time to restore. What that means is it will take this snapshot plus the deltas of the inserts that have happened or deletions that have happened since that snapshot through the commit logs, and it will restore the commit log files, and then goes up to that specific point in time. Of course, you need to be able to choose what specific key space and tables you want to restore. There's restore process of commit log archive is a little bit of a complex process, so having a nice guided way of doing that is important. In your case, you may have a documentation that describes, okay, if you want to do point in time restore, these are the steps you need to follow. And this is again reference implementation. It shows you exactly what it will do. So, okay, I want to restore this specific table. It will play back, these commit logs plus this snapshot. Okay, and then you need to do is you need to stop Cassandra, etc. Right? So this is a fully documented process of restoration, and again, you can do this all yourself, but it's nice to have this in front of you when you're in a panic. We need to restore this data quickly. It's good to have this well documented. So that's commit log archiving and point in time restore. And the final piece is the alerting. So Johnny mentioned it's really important to know when backups fail. So when you're looking at the backups, so you've got the backup history. There's status says green. One of them could have failed. I want to know about when they fail. So then having an alert systems, things like PagerDuty or Slack or Teams, whatever the systems you may be using, you want to be notified on those systems. So then the backup warnings and errors should be sent to the specific endpoints of your choice. So this is, again, reference implementation. You could do this all yourself through various scripts and so on.
Just to interject there, this is one of the things personally I find very, very handy, is this ability to, because often you have different teams who are responsible for the backups. You can route those alerts directly to them, or as opposed to your kind of generic nodes are down alerts might go somewhere else. So it's a very handy feature, this domain level alerting, and having one specifically for backups, because I hate getting woken up in the middle of the night for something that could possibly wait till the next morning. So it's a really handy feature to have.
All right, that is it from me.
Okay, thanks, Hayato. Well, look, there's some questions coming in now. I don't know, Johnny, maybe you might want to pick one or two. I'll shoot one over to you, Hayato, if that's okay. So can AxonOps back up any other platforms as well as Cassandra? Good question.
So right now, AxonOps is built for Apache Cassandra, and that's the Kafka is coming next that it will be supporting, but AxonOps is generally for Cassandra backups only at the moment.
Great. Okay. Johnny, any questions that you want to share with us that you think would be good?
Yeah, no.
Coming in.
One question, somebody asking, is the slide deck going to be shared?
Yeah, we're going to get there. So if you came in a bit late, we are recording the session, so we'll make sure we get the recording out to you. I'm sure we can pop the slide deck in somewhere as well along the way. But yeah, we'll get something out over the next couple of days, so look out for that.
Another question there from Morton. He's mentioned a tool from Instacluster that they've used for backing up to Azure Blob Storage with the snapshots and the commit log archive. What's interesting about his point there was the actual process they take. So he's basically saying they run a backup every 8 hours, and then every 8 hours, and then they do the commit logs up in there. So it's a good example of this scheduling aspect, what you should be scheduling with snapshots, what the commit logs should be going. I think that he said the tool is called ESOP on Instacluster. GitHub. Another question there from Eddie. I often had to delete the snapshots due to Cassandra's cleanest operation, which is kind of tedious. Yeah, so I'm not sure. Hopefully, you picked up in Hayato's demo that when we're taking the snapshots, it will manage the retention of the snapshots on local disk. It'll also manage the retention of those snapshots on the remote storage as well for you. So it looks after both for you. And I think that's it in terms of the question.
That's okay. Good. Well, look, we're still here, so keep them coming. In terms of questions, look, we don't want to just stop answering your questions. And in fact, this is one time now where you can get your mobile phones out and start clicking away. But we don't want to stop answering your questions, when our webinar finishes. So what we've done is we've set up an expert clinic. So what we can do is pull our masters back in for you, but this time we can do it on a one-to-one session. So if you click on the QR code there, you'll see there's an opportunity for you to book a session in for yourself. So whether it's on what we talked about today, on a masterclass on backup and restore, could be just some areas around Cassandra maybe that you want a little bit of some direction on, or some advice on. I don't know, maybe you're looking at AxonOps at the minute and you want to explore some more, and you want a bit of support to do that. There's a whole bunch of reasons, and it doesn't really matter what that reason is. If you want some help, want some support, please click on there. You know what, if you would like us to book you in, put 1-to-1, all right, on your Q&A now, and then at the end of the webinar we'll see that you've put 1-to-1, so 1-to-1 on your Q&A. If you do that, we'll set up the meeting and do it all for you, so you don't have to worry even booking it in. Some other useful links that you might want to just check out. So at the very top there, and we've got an opportunity for you to try out what you've seen. You can connect into 6 nodes, into AxonOps, and start trying out some of the things that Hayato has been showcasing for you. And that's completely complimentary. That's free of charge. It's a great way of getting you started. You'll see there, I'm not going to go through them all here, but you'll see some other, we've got some blogs, that's good. We've got our sandbox as well. There's some other areas in there that you may find really helpful. Now, what is really exciting that's coming up is our next masterclass. So if you've enjoyed this one, hopefully you have, we would love to see you again. We're going to be back on December the 10th, and we will be diving in a lot more to Cassandra development. It's going to be scale or fail, all right? And that's the title. And we're going to be exploring why we believe 70% of Cassandra operational issues result from poor developers, and we don't want that. Okay, we want to make sure that we've got everybody really up to speed, and that we keep everybody out that 70% and into the 30% of doing a great job. So let us help you with that. Come along on December the 10th, and yeah, and also you can just click on and you can register now. It's live, it's all set up, it's ready to go. You can do that if you click on the QR code. So I think I've probably covered most of that off now.
So we've a few more questions coming in.
Yeah, come on, let's go for some more questions. We've got a bit of time left.
I'll start with the following on from Morton's what he's pointed out about how they manage lifecycle management by essentially configuring the blob storage itself to purge the stuff they've copied up. Interesting thing about that, Morton, I think, is one of the things that is important is this differential incremental backup that AxonOps supports. So essentially, when we take a snapshot and copy it up to the remote storage, what we're doing is only copying up the new SS tables that have changed in between the last snapshot. So we're not doing that full data copy up every time. So that's why for our approach to backups, that retention needs to be managed logically, not just based on the life cycle on the blob storage, because you don't want it to delete the wrong SS tables if they're still live and still being used. So it's an important part of our feature. The feature of the way the backups happen is because that if we don't do that, the costs of your external storage can get really high. The network costs, the copying everything up over the wire. So, but it is an important one to use as well. If you copy the entire snapshot up, you can simply say delete it after X period of days on the storage. Another question.
So yeah, just to add to that point, yeah, both ESOP and Medusa do support this kind of incremental differential way of backing up, and they all kind of work in a very similar way. I mean, there's only really one way of doing that kind of differential backs, having those manifest. What's important is that depending on the compaction strategies and so on, some of the SS table files just never change, and I've seen the cases where there's one SS table was kept for like several years in the background, it just didn't get compacted because data didn't change for that SS table, and just compaction didn't happen, right? It was quite a large file. Now that file is still relevant today, right? In that if and you take the backup that into the remote storage, and then the kind of life cycle decides, oh, it's more than 3 months old. And it starts deleting off the remote storage. That's not great because that file is still relevant to the data today. Yeah. So it's relevance is based on the manifest files that these kind of systems back up, and the relevance is based on the date of the manifest, and say, okay, all of the kind of these manifests beyond this data, beyond this date is relevant to us. So then you should look at the content of that relevant manifest and decide what gets purged.
No, another question in there, I think maybe you can answer from Chris. Does the backup solution have the capability of throttling the backups to reduce network bandwidth requirements when storing backups in object storage?
Yeah, that's another important point. So you sometimes you're restricted with the bandwidth and so on. So you need to be able to restrict the bandwidth. So AxonOps has got the capability to reduce the bandwidth. Of course, it takes longer to push the files out if you do reduce the bandwidth, but you are kind of obliged to follow what's available in the infrastructure. So yes, it has got the capability to restrict the bandwidth or throttle. Yeah, the other aspect of the transactions per second on the HTTP endpoints. So there is also ability to restrict that as well.
Yeah. So yeah, that was a port we expect when we were using AxonOps ourselves to look after our Cassandra clusters, and this was definitely one of the things that we noticed fairly early on, was that depending on your target location, you have to have levers to control how much it hammers that remote storage.
And the other side of things is scheduling, right? So you could you've got the flexibility of scheduling backing up one rack at a time and so on. Although it's not that ideal, you don't have the snapshot across all the nodes at the same time. If you are absolutely restricted, there's a way to stagger the backups.
Yeah, Morton also pointed out another good feature is not just the throttling coming up, but also throttling the restore, because you can knock out Cassandra because of the load in as well.
Absolutely. So what happens is when if you are using SS table loader to load the data into a Cassandra cluster, perhaps into production, because you need to load the table and the cluster topology has changed. The only way to kind of load the data is through the SS table loader, right? And what happens, the recipient of the SS tables through the SS table loader, you often get the high CPU utilization. So again, throttling, that is also important.
And there's a really one of the difficult questions, which I've hopefully not saved for last, from Dinesh.
Go for it, Johnny. Go for it.
This is one of those how long's a piece of string ones.
Okay.
What is the best approach when restoring snapshot backup in a different cluster if we have around 20 terabytes of data with 8 nodes? So one of the things that certainly we support is when we take the backups, you can take those backups using the AxonOps Restore tool and load those backups into a completely different cluster. So the tool supports that. In terms of 20 terabytes with 8 nodes, I'd say that's actually quite that's it's kind of on the edges of per node density, but you can definitely push it. But that's a difficult one to say because it will come down to your network, those nodes, how long it takes to do this, because essentially you are streaming the data back in to that cluster, as Hato was mentioning as well around SS table loader. But like off the cusp, I couldn't say how long would 20 terabytes take to stream in. Hato?
Yeah, so it's as I mentioned, it's usually the CPU of the receiving Cassandra nodes that is the bottleneck. So I would highly urge you to rehearse this in your Cassandra cluster. Not in the production cluster, obviously, to load this kind of volume of data into a cluster and then watch the CPU. Yeah, you see that it goes up to 100%. In most circumstances. So yeah, that's something to watch out for. And in the cloud, you can kind of potentially scale vertically scale the nodes whilst you're loading data in. If you're using EBS volumes, if you're using ephemeral, you probably couldn't do that. So yeah, do experiment.
Well, I mean, that's the point, Dinesh. What we were saying, the thing, it's all about practice. Yeah. So if you don't know this, then you should find out, because you need to know what's my recovery time objective that I've got to meet. And you got to figure out if my recovery time objective is to take 20 terabytes and stream it to those 8 nodes. Well, can I do it? Well, maybe not. Maybe I need more nodes to make it go quicker. Maybe I need different kinds of nodes to make it go quicker, because it's all going to be quite specific to your choice of infra, what you've got, networking, all that good stuff. But I think the thing to take away is practice. Yeah, try doing it and do it regularly, because all of a sudden you find it's not 20 terabytes, it's 40 terabytes. So that regular practice, that regular exercise of doing it you'll answer the question yourself.
Great. Well, what a load of questions that we've had in there. Hopefully that's answered what everybody needed to hear. So that's brilliant. Just wanted to point out one real quick thing before I get final comments from Hayato and Johnny before we wrap up, because we are nearly on the hour. Just to remind you all, because you can all see that the next masterclass is going to be on December the 10th. So it's robust app development versus poor development, not developers. I may have said developers, so scrap that if you heard that earlier. It's all about development, what makes good and what makes poor development. We're going to really dig down into that and help support you in those areas. So final thoughts, Hayato, Johnny, what do we got to finally give to everybody before we finish up today? I'll put them on the spot now, because I haven't told them I was going to do this. So here we go.
Cassandra is awesome. Keep using it.
Okay.
And keep it backed up.
Yes, more importantly, back it up.
There we go. Don't forget, back it up and practice. Okay. Well, listen, guys, thanks, Hayato, Johnny, for coming on, being our masters today. And thank you to audience for joining us and your input. And we really do hope you've enjoyed this session. We hope you will join us again, as I said, for December the 10th. I don't think you can forget that date now. Until then, look, take care, stay safe. And from all of us here at AxonOps, it's very goodbye. Take care. Bye.